Hey everyone, so continuing for our calculator techniques, we'll be looking at the parametric equations. Alright, so first of all, you need to change your mode to parametric mode. So click on mode and then scroll all the way down to parametric. As you can see, I'm already in parametric. Otherwise, you probably in function, otherwise you might be in sequence, right? SEQ. Alright, but nonetheless, we're going to sketch the graph of e power t sine t equals to x and e power t cosine t equals to y. Alright. And before we sketch the graph, I'm going to show you the window. If you look at the window, it is t min, there's t max and t step. The three additional things in the window compared to your function. All right. Now, why is that so? Basically, the t min and t max, they are your restrictions to your t in a way where it's like your domain, right? So it's like if they see the graph, they tell you to sketch it from t between 0 and pi, then you change here 0 as t min, t max at pi. All right. You cannot do the restriction where, like in the functions where we put in divide t and all that nonsense. It doesn't work. All right. It's already down here, so it's convenient for you already. So I'm going to show you both the one without restriction or the one in the standard form, which is 0 to 2 pi, which is the standard for DGC. As you can tell, when you sketch the graph, it's going to be something like this. Obviously, you should stretch this further if they're going to show you 0 to 2 pi. Otherwise, usually the question would restrict the domain for you. So I'm going to restrict this to, let's say, 0 to pi. And you see a difference. You notice that you don't draw the tail out anymore because it's only from 0 to pi for t. As such, the window is very important for graphing. If you were to neglect the window, you would draw this additional tail and you would have sketched the wrong graph. All right, just for one more example, 0 to pi over 2, you will only get the top part down here. Obviously, you should zoom in to see it because it's quite small. All right, I'm going to zoom out again. Now I'm going to change to pi over 2 to pi. Oh, whoops. And you notice I get the bottom right hand corner. All right, so this is parametric equations. How do you sketch them? One more thing is that you can still do trace and still see the values, and now you get a t value as well, the parameter. However, if you go to calculate, you can only calculate the particular coordinates at the specific t. So let's say if I put t equals to 1, then I put pi over 2. Wow, I'm smart. Let's say 1.9, then I will get x and y. Then the rest, dy dx, dy dt, dx dt, well, it's the same thing as well, finding out derivatives for the function graph, just that now you can find 3 different derivatives. All right, so there we have it, the parametric equations.